Okay, I can go ahead and say it.
Okay.
Our dear Heavenly Father, we thank Thee for the opportunity that we have to meet together to learn more about the calculus and about specifically triangles and trigonometry. We ask Thee to bless us with Thy Spirit as we do so that we may be able to learn more effectively. And we say these things in the name of Jesus Christ. Amen.
Amen. Awesome.
Okay.
So let's see. This week. Discussing, okay. Begin by discussing what a vector is, how to find the component from given magnitude and direction, vice versa, and how to do the vector operations of addition, subtraction, scalar multiplication, dot product, and angle between two vectors.
Okay.
Felt like a lot of that was pretty straightforward.
Yeah, it's just like what equation matches with this thing, or like to find the dot product or whatever, then use this equation, and the angle between these two vectors, use these two equations. And
yeah, sometimes when I'm trying to find I think it's the vertical magnitude, and you have to take the inverse of the sign. I'm forgetting to take the inverse, and I'm looking at it like this isn't making any sense. It's not. But then I remember that's usually the problem. But other than that, I think it's been pretty good.
That's good. Yeah, it wasn't too bad for me. I like did all of the prep, like the work from the preparation assignment on these on like these papers, and like half of it was on this one paper, and I can't find it anywhere.
Oh.
So I'm like trying to look for like reference or whatever, but
well, geez, like I was telling my husband, like I feel like some of these, it's like this whole thing is just all the math work that I've done, and this is my second spiral, and I'm like I'm killing like a forest here, like
yeah,
there's gotta be a better.
Burned through this, and I'm like, I'm just gonna use the scratch paper they have at the math lab, so I don't have to do whatever.
I actually went to DI, and they had a bunch of spirals, like not even used or anything, out in Rexburg, for like 50 cents, 25 cents, and they were good spirals. So
wow.
I spent a couple bucks on those. And in fact, we were just there yesterday. So they do have some spirals there that are brand new.
I'll have to check that out.
They might have names on them in Sharpie on the front, but it's fine.
I don't care. I'm fine with that.
Let's see. Discuss what a polar coordinate is and how to plot the polar coordinate. Discuss your solutions for converting between Cartesian and polar, and vice versa.
Vice versa. So a polar coordinate is a coordinate on like a circle kind of thing.
And yeah, that's kind of like my husband's also taking pre-cal, and he was like, "Are we doing it on? Are we graphing on circles now?"
Yeah.
I'll admit it's a little. I'm still trying to make sure I get it right, but I think I'm starting.
My least favorite part about this class is having to graph things. Other than that, I'm fine doing like any of the other math. Just putting it on a graph just for some reason confuses me.
Yeah, I'm a big I like equations, I like solving equations, I like memorizing equations, but yeah, when you actually have to start plotting and it's not just a plug and chug kind of thing, I mess that up easily.
Yeah.
But I think some of that is I just need to practice more. I've gone through about half of the homework, and I'm working on the other half right now, and I feel that I don't know. I feel like I haven't practiced it enough. It's not giving me enough. So I might just work some of the problems in the book.
Yeah, definitely. I think I'll do that too.
Yeah, they have answers in the back. I just discovered that recently. So
Really? That's helpful.
yep.
Where did my...
In fact, our last did you do the last test? I guess last week. Have you completed it?
Like last week's test?
Uh-huh.
Yeah, yeah.
Yeah. One of the problems is in the book.
Really?
So I thought that was funny because after I submit it, sometimes I like to look it up and kind of see if I got it right or wrong.
Yeah.
We found the Pentagon question is actually verbatim in the book. So
That was like the one question I was like doubting myself on.
really,
Yeah.
I felt
Kind of weird, but yeah.
yeah, but yeah, that one was in the book. So I got the exact answer. So I was like, it's got to be right.
Nice.
But let's see. Sure that each team member was able to develop formulas for converting found question 6 of the preparation.
I know I have question 6 somewhere. Here it is. Oh, that's just making the equations?
Yeah, that's doing that one, which I think, I mean, it's pretty much everything we've been doing just kind of crammed together. I think it's just not getting cosine, sine, and stuff confused.
Yeah. It's just giving an equation to convert, really.
Uh-huh. Which the inverse of tangent, that's y over x, isn't it?
The inverse of tangent?
Like
Because
whenever you
tangent is y over x.
can't, okay.
So the inverse would be x over y then. Yeah.
Okay. Yeah, I don't know why. Tangent just, it never comes out right for me. I never remember about it, so.
Oh, really? Okay. Yeah.
Okay. Do you want to work through some of the extension problems?
Yeah, let's do that.
Okay. So we're just starting the extension problems?
Yeah.
Okay.
Yeah. Feeling all right?
Not really, but I figured I need my participation points, so I'm here.
There's so much bugs right now. Like, it is.
Yeah.
Winter needs to just stop.
Well, I felt better yesterday, and now I'm back down to this, so I don't even know what that's about. Freaking sucks.
That's just miserable, man.
Anyway. Okay. I haven't even looked at, like, any of this work for this week. I've just been down.
Been there, man. Let's see. The first one, given two vectors, how would you find the resultant vector? Does that depend if you're adding them or subtracting them?
Given two vectors, how would you find the resultant vector? I just put like add them together. I'm not sure if that's right though, because it said that like, because like when I oh dang it, just x'd out of that. Oh well. Like when it said that, I thought of like the example it gave where it's like you have vector A and you have vector B, and then if you want this vector, you just add them together.
Okay.
I'm not sure if that's what it's looking for or not. So
Let's see. I didn't know if it was like, yeah, where it's plotted.
Wait, so are vectors something completely different from what I remember? Because I thought it was like basically a V, and the vector was like the angle in between them.
Yeah, well, see, that's what I was thinking, but
Oh, yeah.
it all comes out the same because you can make it you make it the parallelogram, or is that a parallelogram? Yeah.
Yeah.
So
Oh.
they're both the same thing. It's just in how you want to look at it, I guess.
Gotcha.
Okay. I was getting really confused because I've like messed with vectors a little bit in programming, and it's like basically the angle that shaped like a V, basically.
Oh yeah.
Yeah.
Yeah, that's throwing me off too. It shows it kind of like a different way than I'm used to, and I'm like, whoa, whoa, whoa. But it's kind of the same thing, but I'm sure it's going to change in like this next couple days or something.
Probably.
Unfortunately.
Okay.
The next group meeting, it'll be something completely different again.
Right.
Yeah.
Okay. So the resultant factor is when it ends up like a parallelogram, whatever it is. I can't talk right now.
Yeah, is that adding kind of like what Josh had, the two vectors put together make the diagonal or that long part of
Okay.
it.
Yeah.
Okay.
Okay, what is this next one? So it says, imagine the following scenario that involves vectors. When the prophet Joseph Smith was a young man, his father bought a farm near Palmyra, New York. As with many farms during that time, the family spent many days clearing the land to make it suitable for farming. This would have included cutting down trees and then pulling the stumps out of the ground. Sometimes this was done by hooking two chains around the stump and having two horses going in different directions, pulling the stump out. Imagine that the two horses have an angle of 65 degrees between them. One horse is pulling at a force of 200 pounds and the other is pulling at a force of 300 pounds. The force would be the magnitude of a vector. What is the magnitude of the resultant force? What is the angle between each horse and the resultant force? So
What does it mean by magnitude of the vector? Like, how? Because the only thing I can think of is like how long it would be, but that wouldn't make any sense.
magnitude. Hold on. Just doing problems on this, and my brain just goes out. Isn't
Anyway, I think at least for like the angle between each horse and the resultant force is we take the angle of 65 between them and we do it at like a 2-3 split because one horse is pulling at 200 pounds and the other one's pulling at 300.
oh.
One
Is
horse
the
would get, what? Sorry.
is the magnitude that square root of the one thing squared over the other thing squared, or am I thinking of something else?
I couldn't tell you. I don't know what it is.
Give me one sec.
I haven't even looked at the homework for this week, so I'm like completely lost.
The magnitude is the where it has the absolute value of v equals the square root of a squared plus b squared.
Yeah, okay, cool.
Yeah.
Thinking of the right thing then. Okay, well here. Okay, so they have 65 angle, 200, and this one is 300. Magnitude of the resultant force. So okay, so that's our parallelogram, horse here, and then this is the resultant force. That kind of what I'm getting.
Well, I think the resultant force, because they're pulling at different poundages, I guess. I don't really know. But one of them's pulling at 200 and one of them's pulling at 300. So the one that's pulling at 300, it's going to lean more towards that horse when it actually comes out. At least in my mind, it does. So instead of splitting the angle directly in half, it would be at like a 2-3 split. I don't know what that is right off the top of my head with 65, but like, I don't know. Maybe I'm completely wrong.
What you're saying makes sense. But I did I'm not even sure if I'm doing this like part of the question right. I did 63 times 2/3, and that is 43.33 repeated. But that's not quite the answer it gives. So I'm not even sure where to go from there, honestly.
I guess let me look at the answer key because we have that.
Yeah, I popped in looking at that, and now I'm trying to.
So it's basically 40-25, just about, for their angles.
Okay, parallelogram. Opposite angles.
So I guess I kind of see where that's going a little bit.
Yeah. See, this is where I feel like the homework and the book are one thing, and then here's the actual problems that are totally different than what we were doing.
Oh, yes.
But I guess this is kind of what I was thinking, at least with like on the answer key. That's kind of what I was going towards.
Yeah.
So like the angles split like at a 2-to-3 ratio. So it's like 40-25 almost. And then you just kind of have to add the other vector in. And then the length of that middle line is the magnitude of the resultant force, which according to the answer key adds up to 425 with both of them pulling as they are. So
how did they mathematically find those numbers?
Yeah, like how did they? I'm trying to figure out how they got like the angle specifically. I see what they did, but if this is 65, I guess that's a hard part. I'm trying to figure out how. I mean, I get what you're saying, like how the difference in weight being pulled is going to affect the line R, which is going to change the angles. But I'm just trying to figure out what about that do you use to get the resulting angles?
Right. That's what I'm trying to figure out. I know like how it's supposed to look in my head, but I can't figure out the numbers to make it look like what it's supposed to.
Yeah.
Yeah, like I feel like nothing that we did talked about forces affecting the angle, like magnitudes and vectors and stuff, but I don't really know how the force plays a role in moving the angle one way or another.
Well, I feel like with the pounds of force that they're pulling at, that's the length of one of the lines on the vector. And so that 200-pound line is only 2/3 the length of that 300-pound line.
Okay.
And so when the horse is pulling it, it's going to fly more towards the horse that's pulling at 300 pounds because he's pulling harder. Which ends up with the angle being smaller between the horse and the 300-pound side. I'm just trying to figure out how it all adds up.
And then when it says in the book where it's like, just add the two original vectors together to get that middle one. That's not the answer it's giving in the answer key. Because wouldn't it just be 300 plus 200?
Well,
right? That's
so that middle line, like you do add those two original vectors, the original vector to itself, but it's according to the little drawing that's there. Like you kind of invert it and then stick it together, and it ends up as the parallelogram. And then that middle line that we have going on, it's gonna be longer, but not like 600. I don't know. I'm trying to explain it and I can't because I don't really know what I'm talking about, but it makes sort of sense in my head. Just looking
yeah.
at the answer key.
Gotcha.
Yeah, I guess I was just confused because I've been doing the problems of adding the vectors, and it was just you add them together and that's your resultant vector. But just trying, I'm trying to figure out the mathematical way of producing those. It makes sense what you're saying though. I'll give you that. I just wish I knew how to solve it out.
Yeah, I don't know the numbers that you need to put in to figure it out.
I mean, is that where we need to use like because we have the 115 angle, we have one of the sides, I guess two of the sides. So we have side angle side. Is that what we use to get
I
maybe because one of the pair like the in the answer key, the bottom triangle, it's got 300 an angle of 115 because the 115 is 180 minus the 65, and then that other dotted line side is 200 because of rule of parallelogram. So side angle side is law of cosines. So maybe that's what they're using to get the angle degrees.
maybe.
And then
Mm,
once, let me see. That's my best logic. And then if you get the two angles, you can get well you can use then use a law of sines to get the angles, and then both of those can give you the R, which I guess maybe would work out.
I guess what I'm still trying to figure out, even though we have the 115 and the 65 and the 300, like that doesn't give us. Oh, wait. Okay, so on the picture, it has the 115 and the 300, and that dotted line is just to the right of that 115 again. So we have a side angle side.
Yeah, that's what I'm saying is
Out.
use that to get the angle.
And then I think, yeah, we should be able to use that to get the other two angles on that side of the triangle per se and the side R. So I think that's most likely how you would go about solving it, is using that side angle side, whichever law that ends up being. I forget. I don't know.
so I applied the law of cosines to figure out what R was, and that worked. That got the answer that it gives in the key.
Okay.
And then I wonder if we plug that in for law of sines, if that would give us the angles.
It should.
Yeah.
That would be
So you have to solve it basically like a triangle, but it's a parallelogram, is what it seems like it just ends up being.
Yep. Yeah, so you just do the log cosines to get r, and then you use r to get for the bottom triangle, that gives you the angle on the bottom, or alpha, which is 25 point wait, yeah, 25.239, which rounds to 25.24. And then you can do the same thing for the top angle, and that'll give you the other angle too. So
Yeah. Well, at least once you have one of them, you can just take 65 and subtract it, and then that'll give you
no.
the number 2. That way it's a little bit easier.
Well, there you go.
Okay. Figured it out.
Makes sense to everyone? We good?
Hopefully.
I believe so.
Hopefully I explained it like well enough. I'm not feeling great, but
Oh no, that was great. Yeah, we figured it out.
okay.
Poof. My brain's done.
Yeah, mine's about fried. Ugh.
There we go. That makes sense.
Excuse me. Okay. Eyes are getting very red. So question, what are we on, 3?
Yeah, question 3 is just like talking about the equations that we made for the prepare assignment. And then it goes on. Well, the part A and B, and then it gives, and then part C is like having you apply those equations.
Okay.
Cool.
Well, that's a helpful review there. I'd save that tab for later.
Yeah. Where did I do that work?
Yeah, so next part is just practicing converting those.
Yeah. So it's like, yeah, never mind. Yeah, that's exactly what it is.
Why is it A, B, and A? That's weird.
That's a typo. In the answer key, it has C.
What's wrong? Oh. I've just been staring at the answer key because that's all I care about.
I've just been looking at it because I accidentally closed out of the other tab and I don't want to go back.
Okay, so I guess we can practice converting these and just making sure we're getting the right stuff, and should be good.
Yeah, let's do it.
Okay.
Okay, wait. We have that problem. Okay, gotcha.
Sometimes I hate all of these conversion stuff. That just, why?
I feel like math has a lot of unnecessary steps.
Once you figure it out, it's good, but
Yeah.
Sine theta. Oops. Okay. Nice. Thought the first one worked out. That wasn't too bad.
Second one isn't bad either. The third one's a little tricky though.
Let's just pretend that one's not on there. No. Nice. Yeah, that one's. Oh, I did the wrong substitution on the third one. I was trying to do r equals the square root of x squared and y squared, but it needs to be r equals 2 cosine theta.
Mm.
Is anyone figuring out where the 6 is coming from on the third part?
Yeah, so you what part are you on?
So I got the so I brought the make sure I'm doing this right. I brought over the 1 minus cosine theta, and I put that over and I turned the r into the 2 cosine theta minus r cosine theta. And I got the 3 over 2. And then I factored out the r cosine theta to get me x. But I'm not sure where the y squared or the 6 came out of.
Could you show me?
Let me see if this makes any sense. Wait. Let me rewrite this without the mess up in there.
Okay.
With the R. 3. And then R, I got it to be cosine theta minus cosine theta plus 3. Subtracted out theta. Got 2, 2. And I got X. Okay, I don't know if this makes sense, me jotting it out, but I took the 1 minus cosine theta
Mm-hmm.
and I brought it over here.
Where'd you get the 2 from?
The 2, because I put the r equals 2 cosine theta. That's a formula. So then I had 2 cosine theta minus, or 2 r cosine theta minus r cosine theta. I factored out the r cosine theta with the 2, divided 2 to get the 3 over 2, and then turn the r cosine theta into x, but I don't really know where anything else went to that equation.
I think the problem is with the 2. I'm not sure. You said that's like an equation, or?
Oh wait.
Yeah, let me show you what I
That's
got.
That's just an example they're using.
Oh, yeah, never mind. Thanks. I was like, oh, I guess that's something I wasn't noticing, but yeah, so there's my problem.
Yeah.
Okay. Well, that's why my other page wasn't working out either. Has anyone figured out that third part? I guess I'm still not seeing where the 6 is coming from.
Okay. So, here you bring up the 1 minus cosine theta, and then you times the r by that, blah, blah, blah. And then you move the r cosine theta back over. So it's 3 plus r cosine theta, which is then r cosine theta is just x. That's what x equals. So then over here you have r equals 3 plus x. And then what you do here, we kind of like jumped around on a few steps, but with what I wrote down, but you switch. So r equals the square root of x squared plus y squared. So you replace, I put that here on this side of the equation. And then to get rid of the square root sign, I squared both sides. So then x squared plus 6x plus 9 is just x squared plus y squared. And then the x squareds cancel out, because if you subtract from both sides, then you're just left with y squared equals x, or 6x plus 9. And then, so it wants us to solve for x, basically. So it's 6x equals y squared minus x, or minus 9. And then just divide both sides by 6.
Okay, so the squaring turned it into a perfect square.
Yeah.
Oh, okay. That makes sense. Cool, thank you. Did anyone have anything else with the first or second little part of that?
No, I don't think so.
No, those were good.
Sounds good.
All right. Is that it?
Yep, I think that's it for today. Do y'all want to go ahead and meet tomorrow? Would y'all rather Friday since we met today? How's everyone feeling?
I don't think I can do Friday.
Yeah, I can't either.
So tomorrow would probably be best.
Yeah.
Okay. That works. Y'all want 6:30 again, or?
Or whatever works.
I moved my stream to tomorrow because I didn't want to do that sounding like this. That wouldn't be fun. So I'm doing that from 7 to at least 8 tomorrow, my time, which is 6 to 7 your guys' time. So like 7:10.
Okay, that works for me.
Yeah, that's fine.
Yeah, I can make that work.
All right. Thanks, guys.
Yep.
No problem.
Thanks for dealing